falls, it rises once again, ready to make the next giant block. Five ordinary objects, 5 extraordinary stories. You might be in a park, or in your car, or just walking down the street. But now you can talk to anyone, anywhere in the world at the push of a button. All thanks to the mobile phone. Next, on How Do They Do It?
Swear.
30 years ago, it was just a fantasy. The only person with a mobile clam phone was Captain Kirk. The first mobile phones were bulky and impractical. The batteries weighed a ton, and even then they didn't last very long. There was enough circuitry to fill a brick, and the aerial was long and awkward. But in recent years, the mobile phone has not only shrunk, it's also turned into a TV, a video, and a networked computer. So, how did they do it? To answer this, we go to Finland, because Finland has become a mobile phone R&D hotspot, thanks to manufacturing giant Nokia. Nokia sells 500,000 mobile phones a day, and many of them come from here, their factory in Salo. The problem for companies like Nokia is how to fit more and more functions into a smaller and smaller space. The solution lies with the circuit board. First, blank circuit boards are sent along a 30-meter conveyor belt. The mounting machine has the job of fitting hundreds of electrical components onto each circuit board. The electrical circuits have been miniaturized to an extraordinary degree, and the machine is designed to place them in close proximity with incredible accuracy and speed. Each robot operates at 80,000 components an hour. The components arrive fitted to a roll of tape, a bit like a reel of film, ready to be punched onto the boards. This is the brain of the phone. Microprocessors and memory functions sit side by side, connected with microscopic wires. One chip is dedicated to converting the spoken word from an analog to a digital signal. Another processes the signal. Another handles the keyboard and display. At super speed, everything is checked against a photographic map for accuracy. One component in the wrong place could stop a signal or overheat the phone. In such a tiny space, there's no room for error. A black and white camera picks up the slightest degree of change of position, so it can be corrected by the mounter. As the board moves along the line, it builds up more and more circuitry, adding more and more functions to the phone. And when there's no more space, the board is flipped over and the process starts again. These days, the aerial is hidden away within the phone, but that means radio waves can interfere with the circuitry. The solution is to protect the circuits with tiny metal shields. Now comes the body and some more gizmos. The LCD displays, the cameras, and the keypad, designed for whatever language the phone's destined for, English, Arabic, or Hebrew. But how do mobile or cell phones work? With walkie-talkies, you can only talk or listen, but not at the same time. How do mobile phones get around this problem? Well, a mobile phone is effectively two walkie-talkies rolled into one. When you send a call, one radio frequency sends the voice signal to a nearby transmission tower, while a second listens out for the incoming voice transmission.
No terve Mario, missä sä oot?
Terve, tässä on Mario. Hei, mä oon pahoillani, mä oon aika lailla...
So, a cell phone is like two radios rolled into one handset. It's a brilliantly simple idea that relies on a series of transmitters operating in an area called a cell. And that's where the term cell phone comes from.
Joo, okei. Mulla kestää vähän aikaa, koska mä tuun julkisilla.
Each cell can manage thousands of frequencies. Because transmitters use only a small amount of power to communicate, a lot are needed. This small detail is more important than you might think. It's because cell phones don't have to transmit over long distances that they don't need heavy batteries or bulky aerials. It's this vast transmitter system that allows cell phones to be so small. And it also allows us to add more and more functions to the phones. In downtown Helsinki, all kinds of new uses for your mobile phone are being developed. Here they pay for the tram by cell phone. And now they can beat traffic jams by tuning in on their mobile phones to CCTV cameras all over the city. You can even use your phone to pay for your car wash before you set off. In fact, the mobile phone could see the end of paper money and credit cards altogether. Five ordinary objects, 5 extraordinary stories. Coming up, an object so elegantly designed that it has barely changed for over 100 years. But could new developments spell the end of a classic piece of modern technology? The secrets behind the light bulb. Next, on How Do They Do It? As day turns to night around the world, it springs into action. Few inventions have changed our lives so profoundly as this simple yet ingenious object, the electric light bulb. It's turned night into day, freeing us from one of nature's biggest constraints. Thanks to 1 billion brilliant light bulbs, the world lights up at the mere flick of a switch. And they're so bright they can even be seen from the moon. But have you ever stopped to think how they produce the lights we take for granted? Light bulbs seem like such a simple design. But look again. Each twisted filament made of tungsten metal must heat up to an incredible 2,500 degrees Celsius, enough for the tungsten to generate a glowing white light. But hot enough to melt gold. The light comes from electricity passing through a delicately coiled wire circuit. The thicker the wire, the greater the amount of energy that can pass through it. Yet the one thing that would put an end to this incredible reaction is oxygen. Oxygen is the enemy. It would make the tungsten burn out in the blink of an eye, which is why the glass bulb is so important, something the manufacturers know all too well. One of the biggest factories in the world making the classic-shaped standard bulb is the Philips factory in Piła, Poland. 3,600 people work here, and because the demand for their bulbs is so great, they work in shifts that go on 24 hours a day, 7 days a week. Something they wouldn't be able to do without light bulbs, of course. Last year, they made over 500 million bulbs. using enough little threads of tungsten to travel to the moon 12 times. Here, the production of the light bulb doesn't start with the metal filament. It begins with the bulb itself. Glass is made from a mixture of lime, limestone, potash, a kind of natural soda, and sand. And the factory gets through tons of the stuff. Lime stabilizes the glass as it melts, and the potash reduces the temperature needed to melt it. Thousands of tons of sand are used every year. All the ingredients are mixed together and fed into a giant furnace the size of an office block. But one final magic ingredient is, rather surprisingly, glass itself. Recycled broken bulbs, known as cullet, actually speed up the melting process, reducing the amount of energy needed to melt down the ingredients. You still need a lot of energy to reach 1600 degrees centigrade. That's hotter than molten lava. How to get a light bulb out of a volcano? Next on How Do They Do It? Molten glass is poured into a molding machine to make light bulbs.